Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. Right, in this video we discuss about continuity. So, in this video you should know what is the continuity of a function at a point and how to find the continuity. So, look at the first question. Is it discontinuous or not? Right, in this case the function is discontinuous because here f is not defined at a. However, if we look at the limit from left and limit from right, it approach the same point. So even though it is undefined, but limit for x approach a is exists. Okay, the limit is exists. Next, so in this situation, the limit does not exist, and also the function is discontinuous. Okay, discontinuous. Even though it is defined, okay, it is defined here, the circle defined, okay, even defined, since the limit is does not exist because it approach the different point, so it is discontinuous. And then here the function is defined, okay, fa defined. However, even though the limit is exists, okay, we consider it exists because it approach the same situation, that is positive infinity. This limit, even though we consider it exists, but we consider as an undefined limit. So since undefined limit, even though it's defined here, however, this is discontinuous. Okay. And then, so here the function is defined. Okay. Defined at fa, at a. The limit exists. However, the fa and limit have different value. Okay. So since they have different value here, therefore we consider this is discontinuous. Okay. And here the function is undefined. Okay. fa is undefined. So since undefined, so therefore it is discontinuous. Okay. Yes, also the limit doesn't exist, but the first point is it is undefined. So straight away discontinuous. And here at a, no, then circle here, right? So since fa is undefined, so therefore it is discontinuous. Okay, straight away discontinuous. Right, next, the continuity test. So from the previous graph that we see, we can conclude that there are three conditions that we need to satisfy in order to confirm or determine the function is continuous at certain point. So the first thing is the function must be defined or exist at that point. Secondly, the limit is exists approach that point. And thirdly, this number 1 and number 2 must be equal. Okay, means that the value of function at that point and the limit approach that point must have the same value. So there we can confirm that it is continuous. And don't forget, before this we already discussed, in order to determine given, okay, so if given the function is limit, then the left and right hand limit must be equal, right? So look at the example 31 here. The graph show the function, so determine. So as you can see at 0 here, it is discontinuous, right? Okay, because even though it is defined here, this empty dense circle, but if you check the left and right hand limit, it is different value. So since the limit does not exist, okay, we already failed the second condition. First condition, okay. Second condition failed. So since this one failed, so they confirm discontinuous, okay. And then at x equals to 1, so as we can see here, number 1 it is defined, okay. Number 2, left and right hand limit approach the same point, true. However, number 3, number 1 is not equal with number 2, so therefore it is discontinuous, okay. And then lastly, at x equals to, we see number 1, okay, define. Number 2, limit approach from left and from right approach the same point, true. And then number 3, we see that number 1 and number 2 have the same value, okay. So if these two are okay, then we conclude that this one is continuous, okay. Okay, so this is the detail about what I discussed before. So the limit does not equal left and right hand limit, so since they does not exist, so therefore it is discontinuous. The second one, remember, even though the function is defined, the limit is exists. However, the function and the limit have the same different value. So remember, this one is condition number 1, this one condition number 2, this one condition number 3, okay. And then thirdly, the function condition number 1 define, condition number 2, okay, equals to, and then condition number 3 has the same value, okay. So therefore we can conclude that last one is continuous, okay, as I said in the previous slide. Now in example 32, determine whether the function of x is continuous at given point. So question A, determine continuity at x equals 1, and also for function question B, the continuity at x also equals to 1. So let's see the solution here. So for question A, we want to determine the continuity at x equals to 1. So first we follow the first condition. So the first condition, f1. So f1, it is defined and the value is -1. And then next we move to the second condition. So we check one-sided limit. So limit from right hand limit. So we get a -1. So same also for the left hand limit. Also -1. So we can conclude that the limit is -1, right? And then the condition number 3. So since condition number 1 and condition number 2, we have same value, that so therefore we can conclude that the function is continuous at x equals to 1. Okay. Okay, next for question B. So also here we want to determine the continuity at x equals to 1. So for x equals to 1, I think we don't need to consider this function, only this one and this one, okay. So now first, f1. So f1, as you can see, equal here. So we substitute here for number first condition. And then for second condition, we check one-sided limit. So first, limit from left. So limit from left also we substitute this one right hand limit first. So right hand limit we substitute at this one. Okay, so for add to x minus 1, so we got 1, and then left hand limit, okay, also here left hand limit x minus 1, the function x minus 1. So we set the value and we got 0. See, we have different value. So since we have different value at left and right hand limit, so therefore we conclude that the limit does not exist. So the second condition already failed, so no need to proceed with condition number 3. So just straight away we conclude that the function is discontinuous at x equals to 1. Right, so now we get example 33. So determine the value of x where the function of f is discontinuous. So if x continuous at any point, define the new fx. Okay, so first we solve the first one where the function is discontinuous. So we know we have a denominator here, the x minus 2. So we know denominator x cannot be negative 2. So we know that this is the point where the function is discontinuous, right? So since it is discontinuous, since it's not defined, then we conclude that the function is discontinuous. Okay. So the second question, since we know it is discontinuous at x equals 2, so the question asks us to define the new fx, right? So number 1 failed. Why not we check number 2? We check one-sided limit. Limit from left and limit from right. And we use also condition number 3. We have to equate. And then we can form a new fx from okay. So to form new fx, we proceed further with condition 2, that is limit exists. So if limit exists, we check left and right hand limit from left, and also we equate with limit from right, fx. And then we proceed with condition number 3, that is we equate the f. So we equate this f to, then from here we can form a new fx. So this is limit. Okay, so let's see what I mentioned in this slide. Okay, so as you can see, we've checked limits. So here we see that left and right hand limit doesn't make any difference, so we just straight away as approach to, okay, because already mentioned limit exists. So for condition number 3, we equate. Okay, this is condition 3, so this is condition 2, as I said before. So we equate equation 2 with condition 2 and condition 1. So from this one we can form a new equation from here, that is we obtain the value of net 5. So from that, the value of 5 we put here at the point where the function is discontinuous, that is x equals 2. So other than that, we can use this function except at x equals 2. So in order to make it continuous, we put a value here, that is 5 for x equals 2. So therefore, in this situation, we can make it the function continuous at any point. Okay. So I hope you can understand this function. This is a very good example in how to make the function continuous. Okay. Right, next example 34. Right, so this is a like the one in the limits before. So remember, if the limit is exists, then we equate left and right hand limit. So the same situation also here. We can find out the constant using the concept of continuity. So if they're continuous, then we can equate left and right hand limit since the limit exists, right? Okay. So this is the answer. So let's see the solution. Okay. As I said before, since it is continuity at x equals to 1, okay, so that the left and right hand limit will be equal. Okay. So here we write down the left and right hand limit. And as I said, since it is continuous, the limit must be exist. So if the limit exists, we can equate left and right hand limit. So we equate left and right hand limit. And then we can find out the value of, no. Since we have A and B, so that will be our first equation. Right? And then another continuity. So this time at x equals to 1. Also we use the same concept. Since it is continuous, so the limit exists. So if the limit exists, we can equate the left hand and right hand limit. So this is the left and right hand limit. So later we know we will equate these two. Here, okay, we equate these two, left and right hand limit. Okay. So as you know, later we will form a second equation over here. Okay. So remember previously at x equals -1, we have the first equation, and now at x equals to 1, we have the second equation. So we will solve these two equations in order to find the value of A and B. So you can solve by yourself. So we just straight away give the answer. The value of A is 3/4 and value of B is -1/4. Okay. So we'll find this kind of question in the tutorial and pass your question. Many kind of this question. So apart from this calculation, we also need to know a few properties of continuity. So this is the properties, the sum and difference. This is the properties of product. So this is the property of quotient, which is a rational. And also they also have scalar multiplication. Okay. So all this one, we consider it is continuous. Okay. So this is exercise. Apart from this exercise in this video, you can try many questions in the tutorial and past year question. So all the best. I hope you can practice a lot in order to have a better understanding about continuity. So until then, thank you.